Hey there, folks. This is Mr. Tam back with another episode. This time, just a simple correction key for some mole problems. Or in this case, we're dealing with molarity. So we're going to start with the ones that we didn't get a chance to do together, such as number 4. Should you have any emails or questions, feel free to email me at any point in time. So here they're telling you that you essentially have 0.5 moles per liter of copper chloride solution, and they're asking for the volume that would contain that many moles of copper chloride. So to set this up, as always, you always have your formula of C is equal to N over V. In this particular scenario, you have 0.50 moles per liter, and this is always per 1 liter. And of course, the amount of moles you actually want is 0.025 moles in an unknown amount of volume. So when you go to cross multiply, I don't think I need to show you guys how to do this. You essentially get 0.050 liters, or exactly 50 milliliters of that particular solution. So that's for number 4, very straightforward solve. And it's a very similar scenario for number 5. So I'm not going to necessarily go through the steps. I'll just give you the answers for part 1, and that being 1.44 moles. But I will go through number 2 because once you figure out the amount of moles, you haven't actually changed the volume or the concentration. So the number of moles essentially stays the same. Now, for anytime you're asked to find mass and you're dealing with moles, it's implied what you need right away. So molar mass of the sodium bromide is, I calculated out to be 102.89 grams per mole. And this is, of course, is 1 mole, and you have exactly 1.44 moles. So when you go to cross multiply this, this is an unknown amount of mass, and the number of grams that you end up getting is 148.2 grams of sodium bromide, or NaBr. So if you want to take a chance to, if you want to get a chance to copy all this down, make sure that you pause this video at any point in time so that you can just copy all the work. If you have any questions, of course, always feel free to email me. Now, let's scroll down a little bit here, and we're going to go on to question 6. Now, question 6 seemingly is a lengthier question simply because of the wording, but in reality, they're just asking you to find molar concentration, but they don't give you the number of moles of sodium hydroxide. They just simply give you the amount of mass. So in this case, I know I have 30.0 grams. I don't know how many moles that represents, but I do know the molar mass for NaOH is 40 grams per mole. And this right here, 40 grams per mole, represents per 1 mole. And when I go to cross multiply this, of course, this represents 0.75 moles of the NaOH. Now, once you figure that out, you know that you are actually filling this all the way to a 250 ml mark. And remember, C is equal to N over V, thereby having 0.75 at the top representing N, and then 0.25 liters at the bottom representing the amount of solution. And this, of course, ends up giving you a grand total of 3 moles per liter, or you can write it as 3M. All right, folks, pretty straightforward. We're going to now move on to the next page. And once you get here, it's a very similar process where you have to set up to first find the number of moles. So here you have 2 moles per 1 liter, and you have 0.75 liters at the bottom, leaving you with an unknown amount of N. But doing a little quick math, you can figure out that this N is indeed 1.5 moles of KOH. Now, what is the molar mass of KOH? The molar mass of KOH is 56.11 grams per mole. So when I go to set this up, this becomes 56.11 grams over 1 mole. And of course, because you have 1.5 moles, you just essentially multiply the number of grams by 1.5. And in this case, M ends up giving you a pretty lengthy number here. What I got is 84.165 grams of KOH. Make sure you always, especially at the end, write down the specific substance you're talking about, because you will get yourself confused if you don't write it down when we go to start stoichiometry. All right, number 8 says, in the lab, there's a 2-liter bottle of fruit juice or fruit drink that has a sugar concentration of 0.25 moles per liter. You are asked to transfer an amount of this drink that will contain 25 grams of sugar. Now, there's a bit of a red herring in this case. Actually, a number you don't need. You don't actually need the size of the container. You actually just need the concentration. So in this case, you have a concentration of 0.25 moles per 1 liter. And the 25 grams of sugar has to be converted to moles because you are dealing with a molar concentration. So 25 grams represents an unknown amount of moles. And the molar mass of sugar, or sucrose in this case, is 342.34 grams per 1 mole of the sucrose. When you cross multiply this, of course, N ends up being approximately 0.073 moles. And once you have that, you can set up your usual equation of C is equal to N over V. 0.25 moles over 1 liter is equal to 0.073 moles over a certain amount of volume. And this volume just ends up being approximately 0.9292 liters, or 292 milliliters if you multiply this by 1,000. Excellent. We can now move on to the next part. I'm just going to clear this up. We're going to now move down to number 9. And a good old cup of coffee always gets most of us through the day. So we're going to try to figure out the molar concentration of this. Now, the only difference between this and the other type of problems is that the units require that you convert them. First things first, the 95 milligrams first is not in moles, and it's not even in grams. So we got to convert this to grams first. This ends up being 0.095 grams if you divide it by 1,000. And the molar mass of caffeine happens to be, see here, I wrote it down somewhere. Molar mass of caffeine happens to be 194.19 grams per 1 mole. And you'd have nowhere near that, of course, because we don't want to drink too much caffeine. This is 0.095 grams of caffeine, and it represents an unknown number of moles. N in this particular scenario happens to be, and I'm going to write it in scientific notation so that I don't end up writing a ton of zeros, 4.892 times 10 to the negative 4 moles. Now, once we have this set up, the rest is pretty straightforward. I just have to divide that amount of moles by the amount in liters of the cup of coffee. So now it's C is equal to N over V, where I have the number of moles, a very tiny amount, 92 times 10 to the negative 4, divided by the amount of, or the size of the cup of coffee, which is 0.235 liters. And this, I'll write it at the top since it is a larger number, ends up being 2.08 times 10 to the negative 3 moles per liter, which is our final concentration. And last but certainly not least, this is, we're going to do now number 11. It's what we call a dilution problem. So for dilution problems, I know that I should always list out my variables. C1V1 equals C2V2. And all these quantities are known except for one of them. And the nice thing is, this is 5 milliliters, 5 molar, sorry. This is 75 ml. I don't know my concentration because that's what I'm looking for. And I know that with volume 2, it's the sum of the original amount added to whatever amount you diluted it by. So in this case, you have 75 ml plus the 550, which ends up giving you 625 milliliters of solution. So in the end, you got to make sure you use those numbers, and you really don't need to convert it to liters if you don't want to, simply because your units match. So once you have this scenario, you have C1V1 equals C2V2. Your C1 is 5 molar. Your V1 is 75 milliliters. Your C2 is your unknown. And here you have 625 milliliters. And when you go to divide both sides by 625, you end up with a second concentration that's much more diluted of 0.6 molar. Now, I hope this guide has really helped you out. Feel free to email me if you have any questions. Remember, practice makes perfect. So I'll be back with the next episode sometime soon. Could be today, could be tomorrow. Who knows? Let's carry on forward and do our best. Have a great day, guys. Bye-bye.